Ay tuloy natin. So, problem 16 to 18. So, a rectangular channel 5.4 meters wide and 1.2 meters deep is laid on a uniform slope of 0.001. The roughness coefficient of the channel is 0.013. Number 16, which of the following most nearly gives the flow capacity of the channel? So, this is for Manning's formula. For problem number 16, balikan lang natin yung concept ng the discharge is equal to the area times the velocity or area. This is, ano ba yung area ng rectangular channel? That's simply base times the depth, multiplied by 1 over the roughness coefficient, hydraulic radius raised to 2 over 3, hydraulic slope raised to 1/2. So, ito lang naman yung formula natin for discharge. And then, kung i-recall natin, ang equivalent ng R, the hydraulic radius, that is the area, divided by the wetted perimeter. So, pwede natin kunin muna yung mga parts. So, this is, yung area is, the base times the depth, equal yun sa 5.4. This is multiplied by 1.2. So, ano yung area na yan? This is 5.4, multiplied by 1.2. So, we have that as 6.48 square meters. Then, yung wetted perimeter naman is equal to the base plus 2D. Kumbaga, yung wetted perimeter, so konting refresh lang. Ito lang yung in contact yung tubig dun sa channel. So, the base, tapos yung dalawang depth. So, dito, ang equivalent ng wetted perimeter, that is the same as is equal to 5.4 plus twice up 1.2. And this is equal to, we have 5.4 plus 2 times 1.2. That's equal to 7.8. Yan, 7.8 meters. So, ayan. So, I think kompleto na yung formula natin for discharge. So, we have the equivalent of the flow capacity Q is area that is equal to 6.48 square meter. I multiply by 1 over. Yung given na roughness coefficient is 0.013. Hydraulic radius is area 6.48. This is divided by wetted perimeter, 7.8. Yun yung equivalent ng hydraulic radius. And this is raised to 2 over 3. Hydraulic slope is 0.001. This is raised to 1/2. Okay, so computing for the flow capacity Q, that is 6.48 multiplied by, this is 1 over 0.013. Multiplied by the hydraulic radius, area 6.48, divided by 7.8, the wetted perimeter. This value is raised to 2 over 3. Then, multiplied by the hydraulic slope, we have 0.001. This is raised to 1/2 or 0.5. So, we have the discharge is equal to 13. This is 13.93 cubic meter per second. So, let us check this value sa choices, kung meron. 13.93 sa choices natin, that is letter B. 13.93 cubic meter per second. Sa number 17, sabi niya dito, which of the following most nearly gives the savings in lining per meter length of the channel that could have been offered by using the most efficient rectangular section but adhering to the same flow and slope. So first, we need to consider yung original open channel. Ang gagawin lang natin dito is mag-consider tayo ng 1 meter length ng channel. So for example, i-assume natin na yung length nito is the length is equal to 1 meter. Yung sinasabi niyang lining is ito yung ilalagay natin na material doon sa wall at saka doon sa floor bed ng open channel. So, let's say, this is, ito yung kailangan natin, yung area initial. Okay, so anong equivalent ng area initial? Ang area initial is basically Yung area initial is yung initial wetted perimeter natin times yung length lang, yung 1 meter na length. Okay? So basically, meron na tayong wetted perimeter kanina. Okay, meron na tayong kinuhang wetted perimeter kanina. Okay? Yung equivalent ng area initial is yung initial wetted perimeter natin times yung 1 meter length na i-consider natin. So we have the area initial is wetted perimeter is 7.8 meters multiplied by yung 1 meter length na inassume natin. So, kumbaga, ano yung area na kailangan natin lagyan ng cover? For example, concrete. That is equal to 7.8 square meter per 1 meter length. Okay? So, yan yung area na dapat takpan natin ng concrete. So, isang floor dito sa baba. Tapos yung dalawang walls magkabilaan. So ngayon is kailangan nating kunin yung dimension ng most efficient rectangular. Okay, kung i-recall natin, let us recall. Okay, magsisimula lang tayo sa D or the depth of flow. So let's say this is the D, tapos yung equivalent ng base is equal to 2D. Okay, so kaya paki-recall na lang doon sa lecture natin sa review. Ito yung dimension ng most efficient rectangular section. So, meron siyang area na B times D or the same as 2D times the D. So, pareho lang ito sa 2D squared. Ano naman yung equivalent ng kanyang wetted perimeter? So, that is, we have yung base na 2D plus yung dalawang side na D din. So, 2D. Okay, a total wetted perimeter, 4 times D. And yung kanyang hydraulic radius is the area divided by the wetted perimeter. Equal yun sa area, 2D squared. Wetted perimeter is 4D. So basically, this is the D over 2. So nirecall lang natin yung property ng most efficient rectangular section. So ngayon is, ganun pa rin naman. Yung discharge is equal to area times velocity. So dapat daw the same discharge. Okay? So this is the same as we have the BD multiplied by 1 over the roughness coefficient, hydraulic radius raised to 2 over 3, hydraulic slope raised to 1/2. So kung papalitan natin siya ng most efficient section, dapat the same capacity. Dapat ganito pa rin yung flow rate, the 13.93 cubic meter per second. So this is equal to, we have 13.93 equal to ano yung ating area? So, the area of the most efficient rectangular section ay equal sa 2D squared. This is multiplied by 1 over, parehong roughness coefficient, 0.013. Yung ating hydraulic slope is D over 2, ay hydraulic radius pala. This is raised to 2 over 3, hydraulic slope. So, the same lang naman kung walang given sa problem, gamitin nyo pa rin yung initial na given. Okay, so this is equal to 0.001 raised to 1/2. Okay, kung mapapansin natin sa equation na to, ang unknown na lang is yung depth ng most efficient rectangular section. So, we are to compute for this value. That is 13.93. So, equal to, okay, yung area is 2 times, sabihin na natin, alpha x squared. This is multiplied by roughness coefficient 1 over 0.013. Then multiplied by the hydraulic radius. Hydraulic radius ng most efficient rectangular section is D over 2 lang. So alpha x over 2 tayo dito. And then this is raised to 2 over 3. Then, multiplied by, kung walang ibang binigay, gamitin natin yung mga initial values. This is raised to 0.5. So, shift solve. So, ang lumabas dito is 1.764 meters. Okay, that is the depth of flow for the most efficient rectangular section. So, kung yung D natin is equal to 1.764, tapos yung B is 2D, ano yung twice nito? So, 2 times 1.764. So, is equal to 3.528. This is 3.528 meters. Okay, so magkakaroon na tayo ngayon ng area for the most efficient section. Parang tulad ng ginawa natin sa initial section kanina, is mag-consider lang tayo ng 1 meter length ng channel. Okay, so let's say the length is equal to 1 meter. So ito yung tatakpan natin ng concrete, for example, yung wall at saka yung floor. So basically, okay, sabihin na lang natin, this is the area efficient, or area ng most efficient rectangular section. So the area efficient is equal to, okay, yung perimeter, okay, then yung consider natin na 1 meter, na 1 meter length. So the area of the efficient section is equal to, ano yung ating perimeter? That is the base na 3.528 plus twice ng depth, magkabilaan, 1.764, then multiplied by the 1 meter length na inassume natin. So this is the area of the most efficient section, yung ilalagay natin sa floor at saka sa wall. So this is 3.528, okay, plus the twice of 1.764, okay, twice of 1.764. So as it is, kahit perimeter lang kasi times 1 lang naman yun. So yung lumabas dito is equal to 7.056 square meter per 1 meter length. So parang ito yung tatakpan natin ng concrete or kung ano man yung material na ilalagay sa kanal, okay, per 1 meter length. So i-compute natin ngayon yung savings per 1 meter length. So let's say this is, okay, the savings is basically, okay, ito yung area initial minus yung area efficient. So, ano yung ating area initial kanina? Yung ating area initial is equal to the 7.8. Ito yun. Yun yung dimension ng ating initial channel. Okay, minus yung panibagong channel, which is the efficient section, minus 7.056. So this is the savings per 1 meter length of the channel. That is 7.8 minus 7.056. This is equal to 0.744 square meter per 1 meter length. Okay, check natin ito sa choices. If we have this value for problem number 17. 0.744. Okay, so pinakamalapit na value is letter A, 0.74 square meter per 1 meter length. Then number 18, which of the following most nearly gives, okay, so sa number 18, which of the following most nearly gives the savings in excavation per meter length of channel that could have been offered by using the most efficient rectangular section adhering to the same flow and slope. So, ito naman, i-compare naman natin yung volume ng excavation. So, ganun pa rin. Ano ba yung initial volume ng excavation? So, let's say, the initial volume of excavation is equal to, okay, ano ba yung volume niya considering 1 meter length? That is, okay, 5.4, okay, multiplied by 1.2, multiplied by yung 1 meter na kinonsider natin. So, the initial volume of excavation is equal to, that is 5.4 by 1.2 by 1 meter length. So, ito yung volume na huhukayin initially. 6.48 cubic meter per 1 meter length. Okay, so ngayon, ano naman yung volume ng efficient section? So, ganun din, nag-consider lang din tayo ng 1 meter length. So, let's say, ito yung volume, okay, the volume of the efficient section. That is, 1.764 times yung base natin ngayon is naging 3.528, then 1 meter length. This is the volume of excavation for the efficient section. 1.764 ay multiplied by 3.528 ay multiplied by 1 meter length. So this is equal to 6.223. 6.223 cubic meter. Yan yung huhukayin natin na lupa kada isang metro ng kanal. Okay, so paano natin i-ano yung savings is basically yung difference ng dalawa. So for question number 18, okay, yung equivalent ng savings, the savings in excavation, ito, is equal to yung volume ng initial, okay, minus yung volume ng efficient section. So ano ulit yung mga values na yun? 6.48. So this is equal to, we have 6.48 cubic meter per 1 meter length minus 6.223. So ano yung savings natin sa excavation for problem number 18? That is 6.48 minus 6.223. So this is equal to 0.257 by cubic meter per 1 meter length. Ito yung matitipid natin na parang hindi natin kailangang hukayin na lupa kada isang metro if we are to use the most efficient rectangular section. Check natin, 0.257 sa choices. Ay pinakamalapit na siguro sa choices natin si letter B. That is, okay, 0.25 cubic meter per meter. So ito yung magiging solution natin. Okay, for problem number 16 to 18. Okay, so dito tayo sa problem 19. So a vertical rectangular gate 2 meters wide and 1.2 meters high on one side with water surface 3 meters above its upper edge. Okay, determine the magnitude of the total hydrostatic force acting on the gate. So, for example, ito yung gate natin. So, sabi niya sa problem, yung upper edge niya is 3 meters. Okay, 3 meters above its upper edge. Yun yung liquid surface or water surface. So, paano ba mag-compute ng hydrostatic force? So, this is for question number 19. Hydrostatic force is equal to the unit weight of water multiplied by bar H, okay, multiplied by the area. So, yung bar H is, ilolocate lang natin yung yung center of gravity ng gate. Okay, the center of gravity. So, ito yung, okay, sabihin natin, the equivalent of bar H mula sa surface ng tubig as long as wala naman siyang sinabi na may pressure sa surface or the pressure at the surface is 0. So, anong equivalent ng bar H? That is 3 meters, okay, plus yung kalahati ng height ng gate, that is 1.2 over 2. So, ang equivalent ng bar H natin is 3.6 meters. Okay, that is 3.6 meters. So, kung magsusubstitute tayo dito ngayon, that is equal to 9.81. The bar H is equal to 3.6. Tapos yung area is, ano ba yung area ng gate? That is 2 meters wide. This is 2 meters wide multiplied by 1.2 meters. So we have the hydrostatic force equal to, that is 9.81. Okay, multiplied by 3.6. That is multiplied by 2 meters by 1.2 meters. Yung lumabas is 84.758 kilonewtons. Okay, check natin yung value na to sa choices for question number 19. 84.76, so ito na yung pinakamalapit sa choices. Letter B tayo. Okay, so problem 20 tayo. A spillway 12.9 meters long releases flood runoff from reservoir 5 hectares in area. If the reservoir level drops from 55 meters to 54 meters in 2,520 seconds, find the elevation of the crest of the spillway. So use Francis formula. Okay, so for example, ito yung reservoir natin. So yung kanyang area is equal to 5 hectares. And 5 hectares is the same as we have 50. This is 50,000 square meters. So since 1 hectare is 10,000 square meters. Yung binigay niya na 54 at saka 55, yun yung elevation ng liquid surface above the crest. So pag sinabing crest, ito yung parang lower edge ng isang weir. So specifically, this is a rectangular weir. So from elevation 55, naging 54 na lang siya after 2,520 seconds. So take note na hindi yan yung mga head. So ito yung mga heads natin. This is, let's say, head number 1. Yun yung height ng tubig above the crest. Then ito naman yung, let's say, height number 2. So basically, ang difference ng initial head at saka yung head number 2 is 1 meter. Paano ba tayo mag-compute ng discharge using the Francis formula? Yun daw yung gagamitin. The flow rate actual kapag Francis is the 1.84, the length, the head raised to 3/2. Kaya lang, kapag falling head, take note this is falling head since may time na involved. So, bumababa yung liquid surface, magko-consider tayo dito ng time by integration. So, alam natin na ang equivalent ng discharge ay equal sa negative differential volume divided by differential time. Negative siya kasi nagdi-discharge or take note, nagbabawas tayo ng liquid. So, kung kukunin natin yung equivalent ng time, this is the differential time is now equal to negative. Ang equivalent ng differential volume is area differential height divided by flow rate actual. Sinabi niya Francis formula ang gagamitin. So, i-substitute natin 1.84 L, this is H raised to 3/2. So, integrating both sides of the equation. So, dito from 0 to t, ito naman from initial head to the final head. So, ano yung integral nung left side? That is basically the time equal to, ilabas natin yung mga constants. The area of the reservoir, 1.84 times L. This is the integral from the initial head to the final head of the dH divided by the head raised to 3/2. So, kailangan nating i-integrate yan since may nasa head yung unknowns. So, we have, this is now the equivalent of that time is now equal to negative area. This is divided by 1.84 L. Itataas natin ito, yung H raised to 3/2. Pag tinaas ko yan, magiging negative yung exponent. Negative 3/2. Then, integrate natin. So, plus 1 sa exponent. Kung ano man yung ginawa natin sa exponents, yun yung gagawin natin sa denominator. So, negative 3/2 plus 1 to be evaluated from the initial head to the final head. Ano yung result nito? Negative 3/2 plus 1. Ang result niyan is negative 1/2. So, ito naman is, ang result niya is also negative 1/2. Then, simplify pa natin. This is, we have the time is now equal to, anong reciprocal ng negative 1/2? Ang reciprocal niya is negative 2 times negative, magiging positive twice the area. This is divided by 1.84, the length. Then, evaluate natin, this is negative 1/2, para maging positive yung exponent na yan, gawin lang natin siyang denominator ulit. This is 1/, the final head, this is h/2 raised to, this is now raised to 1/2, then minus yung lower limit natin, yun yung head number 1, minus 1/, the head number 1 raised to 1/2. So, ito yung general formula for the time kapag the Francis formula yung ginamit. Kaya lang hindi natin alam yung value ng head number 1 at saka head number 2. Pero pwede natin gawan yan ng equation. Ano equivalent ni head number 1 in terms of head number 2? Ang head number 1 is basically equal to head number 2 plus 1. Okay, or pwede natin kunin h/2 is equal to head number 1 minus 1. Okay, since 55 minus 54 is 1 meter. Okay, so i-substitute na natin yan dun sa derived formula natin for the Francis formula. Ito yung time is equal to twice the area divided by 1.84 L. This is multiplied by 1/, Supposedly square root, head number 2 raised to 1 half minus the head number 1 raised to 1 half. Okay, mag-substitute tayo. So, ano yung time? Yung time is equal to 2,520 equal to twice. Ano yung area ng reservoir? Yun yung 50,000 square meters or 5 hectares divided by 1.84. Yung length ng crest is binigay na 12.9 meters. This is multiplied by 1 over, ang equivalent ng head number 2. Ang equivalent ng head number 2 in terms of head number 1 is head number 1 minus 1, this is raised to 1 half. Minus, this is 1 over, head number 1 ay raised to 1 half. So as you can see, sa equation na yan, ang una nating masosolve ay yung initial head, ay the head number 1. So mag-shift solve tayo. This is 2,520 is equal to, this is twice of the area of the reservoir. This is 50,000 square meters or 5 hectares. It's divided by 1.84. Yung length ng crest ay 12.9. So i-multiply natin yun sa, this is 1 over the square root, or that is the same as, sabihin na lang natin, alpha x ay minus 1 square root or raised to 1 half or raised to 0.5. Then minus, this is 1 divided by, let's say, alpha x ay raised to 1 half or raised to 0.5. And then shift solve tayo. So, para mapabilis yung iteration, mag-assume tayo ng any value na malapit siguro sa mga, or sa any value na malapit sa value ng h sub 1. So, sabihin ko 2, then press equals. So, yung lumabas dito na h sub 1 is equal to 1.4996 meters. So, sabihin na lang natin approximately 1.5 meters. Pero hindi ito yung required. Ang hinahanap natin is yung elevation ng crest. Ito yung lower edge ng rectangular weir. So, based dito, paano ba natin kukunin yung elevation ng crest? So, yung elevation of the crest, yung elevation ng crest is simply equal to yung elevation na 55 meters, ibawas lang natin yung head number minus head number 1. That is 55 minus 1.5. So, ang sagot natin dito is equal to 53.5 meters. Okay, to check. That is 55 minus the answer. That's 53.5 meters. So, di ba parang ganun lang naman. Mula dun sa initial liquid surface na 55 meters, pababa, with a height of h sub 1, yun na yung elevation ng crest. So, yung sagot natin dito is 53.5 meters sa choices. Check natin. Okay, for problem number 20, this is letter B, 53.5 meters. So, ito yung solution natin sa question number 20. Okay, so dito tayo sa problem 21. A cylindrical tank 4 meters in diameter is to be divided into 2 chambers by a partition along its diameter. At a certain instant, the level of a water surface in one chamber is 5 meters higher than the other chamber. If 20 mm by 20 mm square orifice is installed at the bottom of the partition, how long will it take for the water surface to be at the same level? Use C is equal to 0.60. So, ito yung cross-section ng tangke. 4 meters in diameter. So, we have the radius is equal to 2 meters. So, since nahati lang naman yung cylindrical tank, basically, area 1 is simply equal to area 2. So, ano yung area na yon? That is, the area of the circle is radius squared times pi. Kaya lang kalahati since half of the cross-sectional area. This is divided by 2. So, simply, area 1 equal to area 2 is simply equal to 2. Sabihin natin, 2 pi square meter. Then we have the coefficient of discharge. Sa ibang reference, simply C lang siya. Sa iba naman, C sub D. We have 0.60. According dun sa problem, yung water level sa isang chamber is 5 meters higher than the other chamber. So yun na rin yung ating initial head. So habang nagdi-discharge tayo ng liquid, ang mangyayari is yung liquid surface dito sa, let's say, 1 ay bababa. So let's say, nandito na siya. So obviously, kung ano man yung nawala dito sa first tank, yun naman yung lilipat dito sa second tank. So if they are on the same level, what will be the value of the final head? Okay, kapag ginamit yung term na same level, the final head is equal to 0. Or kung i-reword natin yung question, it is the same as the time before the flow stops. So titigil na yung flow natin for a reason. They are on the same level. Balance na yung energy. Okay, then we have the area of the orifice. This is equal to, we have the area of the orifice is 20 mm by 20 mm. So this is, we have 20 times 20. So yung result nito is square, sabihin natin, square mm. Convert lang natin siya sa meter, since yun yung gagamitin natin. That is 1 over, or we have 1,000 millimeters is to 1 meter. So square lang din natin. So that is the value of the area of the orifice, a square orifice. That is the same as 20 squared divided by 1,000 squared. So we have that as 4 times 10. This is raised to negative 4 square meter. So that's the area of the orifice. So I think kompleto na yung detail. We can now compute for the time. So na-discuss na natin ito noon sa regular review. Kapag 2 tanks yung kino-consider natin, the time is equal to twice of negative 2, area 1, area 2. So this is divided by, we have area 1 plus area 2, coefficient of discharge, the area of the orifice, the square root of 2g, this is multiplied by the square root of the final head minus the square root of the initial head. Okay, computing for the time is equal to negative 2. Area 1 is 2 pi. Area 2 is also 2 pi. This is divided by area 1. That is 2 pi plus area 2 is also 2 pi. Coefficient of discharge is 0.6. Area of the orifice is 4 times 10 raised to negative. Negative 4. To be multiplied by the square root of twice of 9.81. And then this is to be multiplied by the final head. Kapag same level, that is 0. Initial head, that is the square root of, the square root of 5. So what is the time? So this is, we have a negative 2, multiplied by 2 pi. So 2 pi times 2 pi is 2 pi squared. This is divided by, what is 2 pi plus 2 pi? That is twice of, this is the same as twice of 2 pi. Then, coefficient of discharge is 0.6. Area of the orifice is 4 times 10 raised to negative, negative 4. Then to be multiplied by the square root of twice of 9.81. And this is to be multiplied by, that is the square root of 0, by a negative square root of 5. That is equal to 13,216.125 seconds. This is in terms of seconds from the 9.81 meters per second squared. It's 13,216.125 seconds. By the way, the values on our choices is in terms of minutes. So this is to be divided by 60 seconds for 1 minute. So we have the time. This value is divided by 60. That is equal to 220.279 to 20.279 seconds. This is now in terms of minutes. 220.279 minutes. We check that on our choices. Okay, the closest value is, we have 220.3. That is letter A. So this is our solution for problem number 21. Okay, so we have problem number 22. An open can of water is subjected to an upward acceleration of 4.5 meters per second squared. That is supposedly 4 meters per second squared. What is the pressure at a depth of 1.5 meters? So we can use the formula. This is for problem number 22. Okay, the pressure for moving vessel when it comes to vertical motion, that is equal to the unit weight of the liquid multiplied by the height. This is multiplied by 1 plus the acceleration divided by the acceleration due to gravity. So we are using addition if it is upward. If it is downward, that is gamma h, we have 1 minus the A over, that is the A over G. Okay, downward. So since this is upward, okay, we are to use the first equation or the first formula. And the depth of water is equal to 1.5 meters. So we have the pressure is now equal to gamma water is 9.81. The height of water is 1.5 meters. This is multiplied by 1 plus the acceleration is 4.5 divided by the acceleration due to gravity, that is 9.81. So we have the pressure is now equal to, so we have 9.81 to a depth of 1.5. This is to be multiplied by 1 plus 4.5 meters per second divided by the acceleration due to gravity, 9.81. So this is in terms of kilopascals. So we have 21.465. So we have 21.465 kilopascals. That is 21.465. So the closest value is, we have that letter C, 21.46. So this is our solution for problem number 22. Okay, so dito tayo sa problem number 23 to 25. Reservoir A, B, and C are connected by pipelines 1, 2, 3 respectively, which meets at junction D. The elevation of reservoir A is 300 meters, while that of C is 277 meters. Reservoir A is higher than reservoir B is higher than reservoir A. The rate of flow out of reservoir B is 560 liters per second. So parang ito yung figure natin. So sinabi naman niya sa problem, meron tayong outflow. So papalabas ay mula kay reservoir B. That is 560 liters per second or 0.56 cubic meter per second. So sinabi niya rin sa problem na si reservoir B ay mas mataas kesa kay reservoir A. So ang problema lang natin dito usually is hindi natin alam yung direction of flow dun sa reservoir sa gitna. Sa case na to, yun yung reservoir A. Alam natin usually kapag ikaw yung pinakamababang reservoir C, receiver ka or tatanggap ka ng supply ng tubig. So, reservoir C, tatanggap, that is discharge number 3. Ang problema lang natin kay A, hindi natin alam kung inflow or outflow. Pero, one solution dito para malaman natin yung direction of flow is observe natin yung mga nasa choices. Dito sa number 23, compute the discharge flowing in or out of reservoir A. Kung mapapansin ninyo, lahat ng values nito ay less than 560 liters per second. Tapos sa number 24, determine the discharge flowing towards reservoir C. Lahat din sila ay less than 560 liters per second. So, isa lang yung conclusion natin dito. Yung 560 liters per second na yan, galing kay B, ay i-distribute natin kay A at saka kay C. So, which means, the direction of flow will be towards reservoir A, yun yung ating discharge 1, and yun na rin yung kay discharge number 3. Papunta na rin kay reservoir C. So, ano yung magiging equivalent continuity equation natin? Very useful ito, kaya huwag niyo kakalimutan the continuity equation. This is discharge number 2 the 560 liters per second, magsusupply siya kay 1 at saka kay 3. So this is in cubic meters, 0.56 is equal to Q1 plus Q3. Or pwede nating sabihin, the equivalent of discharge number 3 is equal to 0.56 minus discharge number 1. So ito yung ating isang equation. 0.56 minus Q1, that is Q3. So yung isa pang equation na gagamitin natin dito is yung mga head losses. Okay, so since si B ang magsusupply, kunin natin yung parang equivalent energy grade line mula kay reservoir B papunta dito sa junction, yung common point nila. So dapat yung energy head dito sa D ay mas mataas kay A. For a reason, magsusupply tayo kay A. So let's say this is D prime. Ito yung pagbaba ng energy head from reservoir B papunta dito sa junction dahil may head loss sa pipe number 2. So sabihin natin, this is head loss number 2. Para yun kay pipeline number 2. Then mula dyan sa energy head sa point D, ay magkakaroon ng isa pang head loss. Mula dito kay point D papunta sa surface ni reservoir A. Ito naman yung head loss kay pipeline number 1. Sabihin natin, head loss number 1. Then, lastly, since magsusupply din tayo kay reservoir C, ito naman yung head loss from junction D papunta dito sa surface ng reservoir C. Ito yung head loss. This is the head loss number. Sabihin natin head loss number 3. So, ano yung equation na pwede nating magamit sa relation ng mga head losses na to? So, gamitin natin yung mga elevations na given. The 300 at saka yung 277. So, alam natin yung difference in elevation na to. That is, 300 meters minus 277 meters is equal to 23 meters. Ngayon, ano yung relation ni head loss number 3 kay head loss number 1? Okay, so based sa figure natin, gagawa natin ng equation. Ang equivalent ni head loss number 3 ay equal sa, mula sa energy head sa D, papunta sa surface ni A, yun yung head loss number 1. Mula sa surface ni A, papunta dito sa surface ni C, yun yung 23 meters. So basically, head loss number 3 ay equal kay head loss number 1 plus, that is 300 minus 277, 23 meters. So yan naman yung equation natin for the head losses. For the head losses, that is, the head loss number 3 is equal to head loss number 1 plus 23 meters. So, based dun sa figure natin. Take note, ulitin ko lang, bakit mas mataas yung energy head dito sa D? Kasi magsusupply tayo kay A. Kapag pabaliktad naman, dapat mas mababa yung energy head sa D compare sa level ni reservoir A. Then, kunin natin yung may equivalent ni head loss number 3 at saka head loss number 1. So, nandito yung mga properties. Kunin natin. So, since this is for Darcy-Weisbach, head loss is equal to 0.0826. Friction factor, the length, the discharge squared, divided by the diameter raised to 5. Kunin natin si head loss number 1 equal to 0.0826. Ano yung friction factor niya? For number 1, that is 0.0208. Yung length ng pipeline number 1 is 1,500. Discharge number 1 squared divided by yung kanyang diameter is 0.9 raised to 5. So, head loss ng pipeline number 1 equal to, that is 0.0826. Friction factor ay 0.0208. Yung length is equal to 1,500 divided by the diameter. That is 0.9 raised to 5. So this, let's say 4.364 in terms of discharge number 1 squared. Okay, yun yung ating head loss number 1. Then head loss kay pipeline number 3. This is head loss kay pipeline number 3 is equal to 0.08, 26, friction factor 0.0175. Yung length ni pipeline number 3 ay 1,200. Discharge number 3 squared all over yung kanyang diameter. That is equal to 0.45. This is raised to 5. Okay, so kunin natin. Anong magiging equivalent ni head loss number 3 in terms of discharge number 3? So may mga papalitan lang tayo dito. That is 0.45 for the diameter. Yung length ay 1,200. Yung coefficient of friction or friction factor ay 0.0175. Alright, that is equal to, we have 94.002 in terms of discharge number 3 squared. Okay, yun yung equivalent ng mga head losses. So ngayon, gamitin natin yung mga nauna nating equation. Ito yung head loss number 3 is equal to head loss ay number 1 plus the 23 meters. This is for question number 23. Head loss number 3 ay equal sa 94.002 of discharge number 3 squared equal to equivalent ni head loss number 1. Yun yung 4.364 discharge number 1 squared plus 23. Substitute natin ngayon yung equivalent ng Q3 in terms of Q1 using continuity equation. That is 94.002. Discharge number 3 ay equal to 0.56 minus discharge number 1 quantity squared is equal to 4.364 discharge number 1 squared plus 23. So yung unknown na lang is the Q1. Yung ginamit natin dito is cubic meter per second. Okay, check natin. We may use siguro shift solve. That is 94.002. This is multiplied by 0.56 minus Q1 alpha x quantity squared is equal to 4.364 of alpha x squared ay plus 23. Shift solve. So expected dito is less than 0.5 or less than 0.56. So maglagay ako, let's say 0.4. So yung lumabas is equal to 0.065 cubic meter per second, or in liters per second, ito yung times 1,000. That is 0.065. 0.065 times 1,000 is 65 liters per second. So yung sagot natin sa number 23. Check natin sa choices. Okay, so that is letter C. We have 65 liters per second. Sa number 24, okay, madali na lang yan. Ang hinahanap lang naman is yung discharge number 3. Or yung papunta raw kay reservoir C. 24, ito yung discharge number 3 is equal to 0.56 minus discharge number 1. Or in liters, ito yung 560 minus 65. So yung lalabas na discharge number 3 is equal to 495 liters per second. Double check natin. That is 560 minus 65. Nama ba? 495. Yeah, 495 liters per second. For question number 24, the discharge flowing towards reservoir C. That is 495. At yun naman yung solution natin sa number 24. And then, problem number 25. What is the elevation of the water surface of reservoir B? So, paano natin kukunin yung elevation ng reservoir B? Okay, ang given elevation na pwede nating magamit na reference ay dito kay A. So, mula dito sa surface ni A ay pataas, that is head loss number 1. Mararating natin yung level ng energy head ng point D. So, mula sa energy level ng point D, tataas ulit yun naman yung head loss number 2. Saka natin mararating yung surface ng elevation ni reservoir. Yung elevation ng surface ni reservoir B. So this is, okay, para makuha natin yun. This is for problem number 25. This is the elevation of reservoir B is equal to, ang reference natin is yung elevation ng reservoir A plus head loss number 1 plus head loss number 2. Makukuha na natin yung equivalent ni head loss number 1. Meron na tayong equation kanina. Ito yung 4.364 of discharge number 1 squared. Okay, check natin. Okay, ito yung head loss number 1 kanina, 4.364, discharge number 1. Okay, so discharge number 1, nakuha natin siya as 0.065 cubic meter per second. Okay, computing for that value, we have head loss number 1 ay equals sa 4.364. Discharge number 1 ay 0.065 squared. So, ito yung value ni head loss number 1. That is 4.364. Discharge number 1 ay 0.065 squared. That is, medyo maliit. Sabihin natin 0.01, 84 meter. Okay, then, head loss number 2, so far parang wala pa tayong equation para sa kanya. Ay, kunin natin. So, this is, the equivalent of head loss number 2 is equal to 0.0826. Ano yung friction factor ni pipeline number 2? Okay, yun yung 0.0168. Ano yung length ni pipeline number 2? That is equal to 450 meters. Discharge number 2, given na yun kanina na 0.56 squared. This is divided by yung kanyang diameter, that is 600. Let's say 0.6, raised to 5. That is, we have 0.0826. Multiplied by 0.0168. Tapos length is 450. Given na discharge is 0.56 squared. Divided by yung kanyang diameter, 0.6 raised to 5. That is, sabihin natin, 2.5184. This is head loss number 2 is equal to 2.5184 meters. Okay, so balikan lang natin ulit yung equation na to. Mag-substitute na lang tayo. Elevation of reservoir B ay equal sa elevation ni A ay 300 plus ay pataas, head loss number 1, that is 0.0184 meters. Okay, plus head loss number 2, that is 2.51884 meters. So, ito yung elevation ni reservoir B. That is, we have 300 plus head loss number 1 is 0.0184 plus head loss number 2 is 2.5184. So, this is 302.537 meters. Ay 5368. Sige. 5368 meters. Ito yung elevation ni reservoir B. So, ito yung sagot natin sa number 25. So, check natin sa choices for 25. 302.5368. So, pinakamalapit na dito is the 302.54 meters. So, yun yung solution natin for problem ay 23 to 25. Okay, problem number 26. Calculate the approximate depression in capillary tube of radius ay 20 mm. So, surface tension of mercury is 0.515 Newton per meter and its specific weight is 133 kilonewtons per cubic meter. So, for example, ito yung mercury surface. So, kung maglalagay tayo ng tube dito, okay? So, usually kapag viscous yung liquid, hindi makakapasok yung liquid dun sa tube. So actually kapag negative yung lalabas, as you can see sa choices natin, negative yung mga values, yung tawag dyan is the capillary depression. So ito yung H na hinahanap natin dyan. Okay? So by formula, okay, the capillary rise or capillary depression is equal to 4 times the surface tension, that is yung sigma. Then the cosine of theta, this is divided by the unit weight times the diameter. The unit weight of the liquid times the diameter. So based dito sa problem, yung value ng sigma is 0.515 Newton per meter. Yung ating unit weight, binigay naman niya 133 kilonewtons per cubic meter, or para maging uniform tayo, gawin kong 133 times 1,000 newtons per cubic meter. Tapos yung diameter, sabi niya radius yung 20. So yung diameter nito is 2 times 20, that is 40 mm, or sabihin natin 40 divided by 1,000 ay 0.04 meter. Ayan. So kapag memorize yung formula, more of direct substitution tayo. So you have the capillary depression, H is equal to 4 times, this is 0.515 newtons per meter, multiplied by the cosine of theta, binigay niya doon as 140 degrees. This is divided by 133,000 newtons per cubic meter, multiplied by the diameter of the tube, that is 0.04 meter. Kung mag-unit analysis tayo, makakancel yung newtons, meter cube, cancel yung isang meter, tsaka yung meter dito. So yung may iwan na unit is dapat nasa meter. Okay, then multiply na lang natin ng 1,000 since that is nasa millimeters yung mga nasa choices. So yung sagot dito ay nasa meter times 1,000 to be in millimeters. So that is, we have 4 times 0.515 multiplied by the cosine of 140 degrees. This is divided by 133,000 newtons per cubic meter. Then diameter ng tube ay 0.04. That is 2.966 times 10 raised to negative 4 times 1,000. That is equal to that's negative 0.297 millimeters or millimeter. So far, ay pinakamalapit sa choices. Sabihin na lang natin, negative 0.297 is approximately equal to negative 0.3 millimeter. So yung sagot natin dito, so problem number 26 will be letter A. Okay, so dito tayo sa problem 27 to 29. Water is moving in a rectangular channel to have a Froude number of 3.16. The channel is 5 meters in width. The depth of flow is 1 meter. If the water undergoes a hydraulic jump, number 27, determine the depth of flow after the jump. So parang ito yung representation natin. So D1, that is before the jump or at section number 1. Ay after the jump naman yung section number 2. So this is for a case ng rectangular channel. Take note na applicable lang ito sa rectangular section. Yung formula na gagamitin natin yung formula na gagamitin natin for question number 27. So since given na yung initial Froude number, yung initial Froude number is equal to 3.16. So paano ba mag-compute ng Froude number kapag rectangular channel? Equal yun sa the velocity divided by the square root of acceleration due to gravity times the depth of flow. So, una nating makukuha dito is yung B1 since given yung Froude number 1. That is, we have 3.16 is equal to B1, ito yung velocity dito sa section 1 natin, divided by the square root of 9.81, ano yung depth ng flow sa number 1, that is 1 meter. So, makukuha natin yung B1. So, velocity number 1 is 3.16 multiplied by ay the square root of 9.81 times 1. So, 9.81 lang din yun. So, yung B1 natin is 9.897 meters per second. So, bakit ko kinuha yung B1? Para makuha natin yung discharge. Take note for the rule of continuity na yung discharge 1 natin dito sa may mababang depth ay equal lang dun sa discharge number 2. So, equal lang yung dalawang yan. Okay? Discharge 1 and discharge number 2. Continuity equation. So, we have, this is the discharge 1 or equal to discharge number 2. Kaya lang yung gagamitin ko muna dito is si area 1, B1. Okay, area 1 is 1 meter deep, 5 meters wide. Yun yung ating area 1. Okay, 1 times 5. Tapos yung B1 natin is 9.897 meters per second. So, this is discharge 1 also equal to discharge number 2. So, 9.897 multiplied by 5 meters is equal to 49.485 cubic meter per second. So, bakit ko kinuha yung discharge? So, for a rectangular flow kasi, kailangan natin yung unit flow. Yung unit flow, ito yung small q, equal yun sa discharge divided by B. So, it's the same as 49.485. Okay, parang babalik lang tayo. Divided by 5. Mag-iba lang yung unit. So, babalik lang tayo sa 9.897. Magiging square meter per second na nga lang siya. Okay, that is the discharge divided by B. So, kapag rectangular channel, ito yung unit flow squared divided by the acceleration due to gravity is equal to the D1 times the D2 multiplied by D1 plus D2. This is divided by 2. Since hinahanap natin yung depth after the jump or depth number 2. So mag-substitute tayo. That is, we have 9.897 squared divided by the acceleration due to gravity, 9.81. D1 is 1 meter. D sub 2 yung hinahanap natin. D1 is 1. D sub 2, unknown. This is divided by 2. So, computing for the depth after the jump, that is, we have 9.897 squared. This is divided by 9.81 is equal to, we have alpha equals, that is 1. So, sabihin ko na lang alpha x. Multiplied by 1 plus the alpha x divided by 2. So, shift solve. So, yung lumabas is 3.9966. So, yung lumabas na D sub 2 is equal to 3.9966 meters. Ito yung depth after the jump. 3.9966. If we are to check this one sa choices, 3.9966. So, pinakamalapit na, more likely, ang sagot natin dyan is si letter A. Okay, 4 meters. Find the fraud number after the jump. So, sa number 28, paano ba mag-solve ng fraud number? Fraud number 2 is equal to, gamitin lang natin yung velocity number 2 divided by the square root of G. Gamitin lang din natin si depth number 2. So, di ba meron na tayong discharge kanina? Discharge 1 is also equal to discharge number 2 equal to area 2 D sub 2. So, we have 49.485 cubic meter per second. Ang area 2 natin, ay assume natin na yung D sub 2 na nakuha natin is 4 meters. That is the same as 4 meters by 5 meters. B sub 2. So, ito yung ating velocity number. The velocity number 2. Which is, yun pala yung required sa number 29. The velocity after the jump. So, compute natin. Okay, that is we have 49.485 divided by 4 by 5 or divided by 20. That is 2.474 meters per second. Ito yung velocity number 2 sa number 29. So sa choices, pinakamalapit, we have that as a letter B, 2.47. Okay, then doon na tayo sa required sa number 48 at 28. Ito yung fraud number after the jump, fraud number 2. So that is a B sub 2. We have 2 point. We have fraud number 2 is equal to B sub 2. That is 2.474. This is divided by the square root of 9.81 times depth number 2 is 4 meters. So take note na yung formula na yan ay applicable lang sa rectangular section. Okay, compute natin. And that is, we have the 2.474 divided by the square root. The square root of 9.81 ay multiplied by depth number 2, that is 4 meters. So 0.395, 0.395. So check natin ito sa choices. 0.395, that is letter C. So, kung i-recall pala natin yung ibig sabihin ng mga fraud number, kapag yung fraud number is greater than 1, okay, i-recall lang natin. If the fraud number is less than 1, ito yung subcritical. If the fraud number is equal to 1, ito yung critical. Tapos, if the fraud number is greater than 1, ito yung super critical. Yun yung parang mga ibig sabihin ng fraud number. Ito yung solusyon natin sa number 27 to 29. So dito tayo sa problem number 30. Determine the force exerted by a 50 mm diameter jet moving 16 meters per second against a perpendicular plate moving 8 meters per second in the same direction as the jet. Okay, so for example, ito yung figure natin. Sabihin natin na B sub 1, yun yung velocity ng tubig. B sub 2, velocity ng plate. So, paano ba tayo nagko-compute ng force exerted by the jet of water? Yung tawag natin sa force na yan is the dynamic force. Okay, paano mag-compute ng dynamic force? Okay, we have the dynamic force is equal to the density of the liquid. So kung tubig yan, that is density of water. This is multiplied by the discharge. Okay, multiplied by the quantity B sub 1 plus or minus the B sub 2. So kung the same direction yung dalawang object, let's say that is B1 at saka B2, ang ginagawa kapag the same direction is minus. Since parang mas mahina yung force na tatama dahil the same direction. Then, kapag opposite direction naman, kung meron tayong opposite direction, ang ginagawa naman dito is plus. Ibig sabihin, magkakasalubong, mas malakas yung force. So sa case natin, we have the dynamic force equal to the density of water. Discharge, since the same direction, dapat minus. That is the B1 minus B2. Okay, so kunin lang natin yung mga wala pa. So that is yung discharge. So mag-focus lang tayo dun sa tubig for the discharge. So paano ba mag-compute ng discharge? That is equal to the area times the velocity. Diameter ng pipe is 50 mm. That is the same as 0.05 squared pi. This is divided by 4. Multiplied by yung velocity ng tubig, given siya as 16. That is, we have 0.05 squared. This is ship pi divided by 4. Multiplied by 16. That is 1/100 of pi, or sabihin ko na lang, the discharge is equal to pi divided by 100 in terms of cubic meter per second. Okay, yun yung ating discharge. So ngayon, mag-direct substitution tayo for the dynamic force. Dynamic force is density of water is 1,000 kilograms per cubic meter. Yung ating discharge is equal to pi divided by 100 cubic meter per second. This is multiplied by the velocity, that is 16 minus 16 for the water, 8 for the plate. This is in terms of meters per second. Kung mag-unit analysis tayo, cancel lang yung cubic meter. Ang maiiwan na unit dyan ay the kilogram meter. Meron tayong 2 seconds sa ilalim, that is kilogram meter per second squared, or basically, kapareho lang ito ng newtons. Okay, the kilogram meter per second squared. Okay, so computing for the dynamic force, F is now equal to, that is, we have 1,000, okay, multiplied by, this is sheep pi, divided by 100, then multiplied by 16 minus 8. 16 minus 8 is 8. So it's 80 pi. This is 80 pi newtons, or kapareho nito, 251.327. Okay, 251.327 newtons. Okay, check natin sa choices for problem number 30. Okay, pinakamalapit na dito, 251.3 newtons. So, yun yung sagot natin sa question number 30. Then, sunod natin itong si problem number 31. A water flows through a horizontal nozzle located at the vertical side of a large tank under a constant head of 3 meters. So, the nozzle is located 10 meters above the ground. Determine the time for the water to reach the ground after leaving the nozzle. So, since horizontal nozzle daw yung ginamit, magkakaroon ng 2 components yung velocity of flow. Meron tayong v sub x at saka v sub y. Yung analysis natin dito, para siyang pre-falling body. So, kapag pre-falling body, ang initial vertical component ng velocity will be equal to 0. So, parang simpleng P6 lang yung gagamitin natin dito. So, that is yung equation natin na S. This is for 31. S is equal to B1T, okay, plus 1/2 of the acceleration due to gravity times the time squared. So, kaya lang kapag vertical motion, parang iniiba lang yung appearance ng formula na yan. For example, this is Y. Kapag vertical distance ang usapan, gamitin mo yung initial velocity, pero vertical component. By1 times the time plus 1/2 of g times the time squared. Kaya lang, sa case natin na to, since yun nga, ang initial direction ng tubig ay horizontal dahil sinabi niya gumagamit tayo ng horizontal nozzle, yung initial vertical component of the velocity will be equal to 0. So, which means, yung term na to magiging 0. So, yung y natin is 10 meters is equal to, this is 0 plus, we have 1/2. The acceleration due to gravity is 9.81 times the time squared. So, makukuha natin yung time na magta-travel siya ng distance na 10 meters. So, that is 10 times 2 divided by 9.81. Okay, then, kunin natin yung kanyang square root. That is equal to 1.428, 1.428 seconds. Ito yung time travel bago marating yung 10 meters below. So, 1.428 sa choices natin, okay, pinakamalapit na dito si letter C. That is 1.43. So, this will be our solutions for problem 30 and 31. Okay, dito tayo sa problem 32. A wooden block having a specific gravity of 0.6, 40 mm by 60 mm by 3.5 meters long is made to float in water. how many kilograms of stone having a specific gravity of 3.25 should be attached at the bottom to make the wooden block float 300 millimeters exposed to atmosphere. Okay, so ito yung figure natin. So, ito yung block natin. The length of the block is 3.5 meters. Cross-section is 40 mm by 60 mm. Since given yung kanyang specific gravity, okay, mako-compute natin yung kanyang weight. So, to start the analysis kapag buoyancy, always start with mechanics. Ano ba yung mga forces na i-consider natin? So, we have una, let's say this is weight number 1. Yun yung weight ng wooden block. Then, sabihin natin, this is weight number 2. Ito naman yung weight ng stone. Since meron tayong dalawang objects na exposed sa tubig, magkakaroon tayo dito ng dalawang buoyant force. So, una yung buoyant force number 1 para dun sa block. That is equal to the unit weight of the liquid, okay, volume. The volume submerged. Then, yung second buoyant force natin, sabihin natin, this is buoyant force number 2. Ito naman dun sa stone, dun sa bato. That is the unit weight of the liquid, then the volume of the stone. So, sabihin ko na lang volume of object number 2. Dahil bato yon, fully submerged siya. So, total volume niya yung usapan. Then, okay, gamitin natin siya ng mechanics. This is the summation of forces, vertical equal to 0, assuming upward forces to be positive. Ito yung buoyant force number 1 plus buoyant force number 2 is equal to weight number 1 plus the weight number 2. So, isa-isahin natin yung mga values na to. So, makukuha ko yung weight number 1. Ito yun sa wood. Okay, ito yung weight number 1 is equal to the unit weight of the object, okay, multiplied by the volume of the object. So, volume 1, unit weight of the object 1. So, this is equal to, ano yung unit weight ng object 1 natin? Meron siyang specific gravity na 0.6. So, this is 0.6 times gamma water, 9.81. Ano yung volume ng block? Okay, binigay yung volume ng block or yung wooden block. That is 40 mm or 0.04 by 0.06. Ito yung 60 mm. Okay, multiplied by yung total length niya ay 3.5 meters. So, gamma volume, yun yung pag-compute natin ng weight. Ito yung weight ng wood equal to specific gravity 0.6 times the 9.81. This is multiplied by the volume of the wood 0.04 by 0.06. Tapos yung total length niya na 3.5 meters. So ito yung weight number 1. Sabihin na lang natin 0.049 kilonewtons. So paano naman yung weight number 2 dun sa stone? Okay, dun sa stone, equal pa rin yun sa, okay, that is, the weight number 2, equal yun sa gamma, object 2, okay, volume number 2. So, yung kanyang specific gravity is 3.25 times gamma water is 9.81. Hindi natin alam yung volume ng bato. So, volume number 2. So, in terms of volume number 2, that is 3.25, then multiplied by 9.81. So, that is equal to 31.883. Sabihin na lang natin. Weight number 2 is 31.883 volume number. Okay, volume number 2. So, since hindi pa natin alam yung volume ng bato. Then, how about the buoyant force? So, buoyant force number 1, okay, again, ito ay dun sa wood. That is the unit weight of the liquid volume submerged. Dahil hindi fully submerged yung kahoy. Okay, sinabi niya sa problem na 300 millimeters exposed to atmosphere. So, ang nakalubog lang sa tubig ay yung height na 3.2 meters. So, that is, okay, gamma liquid. Okay, gamma liquid, tubig lang ito, 9.81. Ano yung volume na nakalubog? Cross-section ng wooden block is 0.04 by 0.06 times, okay, yung nakalubog lang na height ay 3.2 meters. So hopefully malinaw yon since meron tayong 300 millimeters or 0.3 na exposed sa atmosphere. Okay, sinabi niya yon dito sa problem. Okay, the 300 millimeters exposed to atmosphere. So compute natin yung equivalent, okay, the equivalent of buoyant force number 1. So we have that as 9.81, okay, multiplied by the volume submerged, 0.04 by 0.06, okay, times volume, height submerged 3.2. So that is equal to 0.075 kilo newtons. Then, paano naman yung buoyant force number 2? So, yun naman yun sa stone or sa bato. So, for buoyant force number 2, that is equal to the unit weight of the liquid, the volume of the object, dahil fully submerged siya. That is 9.81 volume of the object. Okay, hindi pa rin natin alam yung total volume. So, ngayon, mag-substitute na tayo dito sa equation na to. Ano equivalent ni buoyant force number 1? Buoyant force number 1 is 0.075 plus ano equivalent ni buoyant force number 2? That is 9.81 of volume of the object number 2 or volume ng bato. Is equal to weight number 1. Yun yung weight ng wooden block, 0.049 plus weight number 2, yun yung weight ng stone. That is equal to 31.883 of volume number 2. So this is the volume of the stone. Yun yung una nating makukompute. So that is 0.075, okay, plus the 9.81 of alpha x. This is equal to, we have 0.049 plus the 31.883 of alpha x. Okay, shift solve, computing for the volume of the stone. That is 1.178. 1.178, this is times 10 raised to negative 3 cubic meter. Check natin. So 1.178. Okay, times 10 raised to negative 3 cubic meter. So since kilograms yung unit nung nasa choices, pwede tayong gumamit ng density. Diba, density is equal to the mass divided by the volume. So we can have the mass as the density of the object times its volume. So ito yung sa stone tayo. We have the mass. Ano yung density ng object or density ng stone? Yun yung specific gravity niya, that is 3.25, multiplied by gamma water, that is 1,000 kilograms per cubic meter. Then, yung volume ng stone na nakuha natin, that is the 1.178, this is times 10 raised to negative 3 cubic meter. So, para makancel natin yung unit, okay na, cubic meters. I-remind ko lang, di ba specific gravity is the density of the object divided by density of water. Kaya kung gusto nating makakuha ng density ng object, specific gravity ng object times the density of water. Ito yung ginawa ko dito. Specific gravity ng stone times density of water. So we have the mass of the stone is now equal to, that is 3.25 multiplied by 1,000. This is multiplied by 1.178. This is times 10 raised to negative 3. That is 3.829. 3.829 kilograms. 3.829 kilograms. So check natin yan sa question number 32. 3.829, pinakamalapit na is letter C. That will be our solution. Problem number 33. A stone weighs 100 pounds in air. When submerged in water, it weighs 67 pounds. Find the specific gravity of the stone. So, ito yung case na yung object will be fully submerged. Okay, kung i-observe natin, weight in air is 105, tapos weight submerged naging 67 na lang. Bakit nabawasan? That is basically because of the buoyant force. So, sa case na to, hinahanap natin yung specific gravity ng stone. Ito yung case na kung gagamitan natin siya ng mechanics, that is yung weight in air. Okay, the weight in air minus the buoyant force. Ang result nun is yung weight, the weight submerged. So that is the same as 105 minus the buoyant force is equal to weight submerged na 67. Makukuha natin yung magnitude the magnitude of the buoyant force. So that is 105 minus 67. So that is equal to 38 pounds. Kapag fully submerged ang isang object, totally nakalubog, the equivalent of the buoyant force will be equal to the unit weight of the liquid, the volume of the object, yung kanyang total volume. Since, yun nga, fully submerged siya. So this is equal to, we have 38 pounds is equal to, gamma water. So I think tubig lang ito, plain water. Okay, so gamma water sa English ay equal to 62.4, the volume of the object. Makukuha natin yung volume ng object. That's 38 divided by 62.4. That is 0.609, sabihin natin, 0.609 cubic foot. So, paano natin gagamitin yan para makuha natin yung kanyang specific gravity? The specific gravity of the object, or kunin muna natin yung kanyang unit weight. The unit weight of the object is basically equal to its weight divided by the volume of the object. Kapag ganitong case, yung actual weight yung gagamitin. That is yung weight in air. Okay, ano yung weight in air natin? That is, we have 105 pounds per 0.609 cubic foot. And this is equal to, yung kanyang resulting gamma, ay 105 divided by 0.609. That is equal to 172.414. 172.414 pounds per cubic foot. Ayun. So, pwede na tayo mag-proceed sa specific gravity. The specific gravity is equal to the unit weight of any object divided by unit weight of water. So this is equal to 172.414 pounds per cubic foot. So dapat yung divisor natin the same unit para maging unitless yung specific gravity ng object. That is divided by 62.4 pounds per cubic foot. So this value divided by 62.4. That is equal to 2.76 equal to 2.76. So check natin sa choices if we have that value. 2.76, we have that as letter A tayo. So for question number 33. Dito tayo sa problem 34. A vertical jet of water from a nozzle supports a load of 150 newtons. The velocity and diameter of the jet near the nozzle tip is 17.46 meters per second and 3 centimeters respectively. Find the distance of the load from the nozzle tip. So parang ito yung setup natin. So paglabas daw ng tubig dun sa nozzle, ang velocity is 17.46. Ito. So hinahanap lang natin yung distance na y. So gagamit lang tayo dito ng equation natin sa P6. Ito yung the final velocity squared is equal to the initial velocity squared kapag yung sign convention natin sa G, kapag upward is negative, kapag downward it is positive. So this is final velocity squared equal to initial velocity squared minus 2G times, instead of H yung gagamitin ko, gagamit ako ng Y. So minsan sa ibang reference, H yan, pero Y na lang yung gamitin natin para hindi tayo ma-confuse. H kasi is head sa hydraulics. Okay? So, initial velocity is 17.46. Okay, hindi gumagalaw yung block kasi isosupport siya ng tubig. So, pag tama ng tubig dito sa block, kailangan lang natin makuha yung equivalent na final velocity. Final velocity ng tubig. Di ba? From initial velocity of 17.46, ano yung kanyang final velocity? Pero kapag i-analyze natin siya as dynamic force, i-assign ko siya as B1. Tapos, B1 or final velocity, ang usapan natin dito ay yung tubig. Yung B sub 2 naman natin is yung velocity ng object. So since hindi siya gumagalaw, Okay, yung velocity ng block, since hindi siya gagalaw, the velocity is equal to 0. So, pag tama ng tubig, meron siyang corresponding force or yung tinatawag natin na dynamic, the dynamic force. So, paano mag-compute ng dynamic force? That is equal to the density of water, the discharge multiplied by B1 minus B sub 2. Pero for this case, B sub 2 ay 0. Wala pa tayong discharge, pero meron tayong initial velocity. Okay? So, makukuha natin yon since given rin naman yung kanyang diameter. Kumbaga, yung initial discharge niya dito, i-assume natin na equal pa rin yung kanyang final discharge pagtama niya dun sa block. So, we have the discharge. This discharge is equal to the area 1, B1 tayo. Or area initial since nagbabago naman yung shape ng tubig habang papalayo siya dun sa nozzle. So that is equal to area, diameter of 3 centimeters, that is the same as 0.03 squared pi divided by 4. Yung kanyang initial velocity ay 17.46 meters per second. Ito yung rate of flow or the discharge. 0.03 squared. That is C pi, this is divided by 4, multiplied by the 17.46. So we have that as 0.123, 0.123 cubic meter per second. 0.01234. Sige, ilsama na natin yung 4 para mas accurate siguro. So we have now the dynamic force. Ano equivalent tong dynamic force? Pagtama niya. Okay, di ba? Pag tama ng tubig, may force yan. So, para hindi raw bumaba yung block, which is, yung weight niya is 150 newtons. Obviously, if you are to do summation of forces vertical equal to 0, yung force na i-apply ng tubig ay equal lang sa weight, which is equal to 150 newtons. Okay, so mag-substitute na tayo from this equation. This is 150 newtons equal to the density of water is 1,000. Yung nakuha ko na discharge is 0.01234. Then, B sub 1. Makuha natin yung B sub 1, yung velocity ng tubig pagtama niya dun sa block. So, we have this 150. This is divided by 1,000 multiplied by 0.01234. Yung lumabas dito is 12.15. This is 12.156 meters per second. 12.156 meters per second. So, gamitin na natin yung equation na to. We have the final velocity. Take note na yung B1 na to is the same as our final velocity. Yung velocity ng tubig kay pagtama niya dun sa block. That is the final velocity. Kaya nagkaroon ng force equal to 150 newtons. The final velocity is 12.156 quantity squared is equal to, ano yung initial velocity natin? That is 17.46 squared. This is minus twice the acceleration due to gravity, 9.81 times the value of y. So, makuha natin yung value ng y equal to, that is 12.156 squared, minus the 17.46 squared. This is divided by negative 2 divided by 9.81. That is 8.006 meters. Okay, check natin. Kung meron tayong y is equal to 8.006 sa choices. So, pinakamalapit na sa 8.006 is letter B, 8.01. So, this will be our solution for problem 34.